Hello, stat students. Let's keep getting into chapter 2. Section 2.2 is histograms, frequency polygons, and ogives. So I want you to know that section 2.1, both A and B, making a frequency table or a frequency distribution table is always going to be your first step. That's why it was section 2.1. Everything that we do from here on out, we need the data organized as a frequency table in order to make all of these happen. So we're going to talk about 3 visual representations: histograms, frequency polygons, and ogives. The first is a histogram. This is a bar graph looking. It's got vertical bars. And a really important thing in this, there are no gaps. A traditional bar graph, whether you know it or not, has gaps between the bars. So in order to do that, we're going to use class boundaries. Remember, class boundaries are those things that are usually decimals, the halfway point from the upper limit to the next lower limit. So in order to construct a histogram, first thing you're going to do is draw your axes. Obviously, it's a bar graph, so you need an x and a y-axis. Your x-axis are your class boundaries. The y-axis is the frequency. So if you have 30 pieces of data, and your highest frequency is 11, you don't have to go much farther above that. We don't need to go up to 30 because it's the frequency of each class. So every single bar of our histogram is going to be representing one class. Step 2, we're going to label our axes, values, titles, all the stuff that we like to have on a graph of any sort. And then step 3, using the frequencies as heights, draw vertical bars for each class. No gaps. I'm going to be really strict about this. There's no gaps. And the reason there's no gaps is because, like I said up here, we're using the class boundaries. Where one class ends 23.5, the next class begins at 23.5. So there will be no gaps. If you use your class boundaries, it just happens. So it says to construct a histogram. Notice I've already got a frequency table done. I even wrote in the class boundaries, which I probably should have left blank for you so that you could figure them out. But notice, if this class ends at 104, this class starts at 105, the halfway point is 104.5. So it's always a half above and a half below your upper and your lower boundary. So if I'm going to make a histogram, it said the first thing I should do is make an x and y axis. I'm going to scooch that so I can see. So here's my y, here's my x. It said that our x-axis is our class boundaries. So we can, like we do in any regular graph, we can skip a few. We don't have to start immediately. We know 0 is always the origin. 99.5 is my first class boundary. So I'm just going to mark it here at 99.5. And then I'm going to keep doing all of my class boundaries. 104.5, 109.5, 114. Bear with me. I got this 124.5. I need one more to finish my last bar. Don't forget to use that 129.5. So that is my, does it say? It does say record high temperatures. So along this axis, this is going to be record high temps. Pretty much always your y-axis will always be frequency. Every time, frequency. So when I look at my frequencies, they go from, 2 up to 18. So I keep that in mind. Maybe I'll say this is 20, this is 10. Oops. I'll count by 2s. 2, 4, 6, 8, 10. There we go. You'll get better at that as you go. And then I'm going to start making my bars. So this is the most important part. My first class boundary from 99.5 to 104.5 is 2. So my first bar, remember I counted by 2s. That's why we use those boundaries. My second bar from 104.5 to 109.5 is 8. So I'll go up here to 8. If you don't want to shade them in, you don't have to. So notice those two bars are back to back. It's because I use that class boundary. There's no gap. One doesn't end at 104 and the next one starts at 105. They begin and end at the class boundary. So go ahead, keep filling in your bars. Next one is a 13. I'm eyeballing this. Feel free to use like graph paper or grid paper if you want to. I know some people don't like their bars to be quite so sloppy. Next one is a 7. 2, 4, 6, 7, so right about here. And my last bar is going to be at 2. So a little like that again. There we go. So a nice neat frequency or a nice neat histogram. I mean, neat is relative. So I did ask you a couple questions in these bubbles. Could there ever be a gap in a histogram? Like all of a sudden this bar is completely gone. That could happen, right? If I had a 0 in that particular class, I could have a gap in my histogram. It always has to, your first and your last will always have a bar because we cannot have a 0 frequency in our first or our last class. And hopefully you're with me about this, why are class boundaries included in the frequency table? Well, we put them in the frequency table just to make life easier. When you make your histogram, everything's there. You don't have to think about it. That way you get all your bars, no gaps, all that. Down here I've got another bubble, another couple things to think about. I'll ask you, how are histograms different from bar graphs? Well, I think I said that at the beginning, right? Bar graphs are more, bar graphs we can actually use, and we'll do them with qualitative data. They usually have gaps. Bar graphs can actually be vertical or horizontal. So all those things can happen. Histograms also always have bars touching. Class boundaries are on the x-axis so that we can actually see what our data is. And then how do you know how many bars to make? Hopefully you know why we have 6 bars in our histogram. If not, ask me. So there's histograms. So remember, everything comes from a frequency distribution table. You need to have your data organized before you can do any of this stuff. So frequency polygon is our second shape. It is a polygon. I teach geometry. Hopefully you remember what a polygon is. It's a graph that displays data using line segments that connect points. Each point represents the frequency. So it's the same thing as the histogram, except it's making points and connecting them instead. And there's one other piece of information that we need to know, which we need to find the midpoints. The midpoint is where you will put your point for your frequency to connect your dots. So find the midpoints of each class. Remember, midpoint is add up your lower and your upper limit, divide by 2. It's the average or the midpoint of those two things. Step 2, label your x and y axes. The x-axis is class midpoint, y-axis is frequency. And last but not least, at each midpoint, plot your frequency. And in order to make it a polygon, we're going to connect to the x-axis on both sides of the graph. So we're going to start and have a point at the origin. We start a little over like we did for the histogram. And then at the end, we're going to connect it as well. Polygon is a closed figure. So we need to connect on both sides. So let's whip up a quick polygon. So I've got our frequency table here. It's the same data. It's just I added the class midpoint. We've got the same frequencies. So the only difference here is we got to do a little bit of calculations. I can add up these two numbers and divide by 2. Whoops. Add those up. That would be 204. Divide by 2. And I've got my midpoint. So what's that going to be? 102. 105 to 109, the midpoint would be 107. This one is going to be 112. It's the actual midpoint. You might be able to just common sense your way through when you've got small class width like this. If you're not sure, add up the two sides of the class limit, divide by 2. So now we've got, when we make our graph, our frequency polygon, this is the information that we need. So I'm going to make myself a little XY axis here. Along the bottom is the midpoints of the record high temps. So I'm going to start with 102. I'll start right about here, and then a 107. Feel free to pause this if I'm going too fast. Feel free to wait patiently if I am going too slow. I'm going to extend this a little bit because remember I need to attach. Up the y-axis is always frequency. And again, my frequencies go from 2 to 18. So I'll do what I did before. I'll count by 2s. This will be 20. This will be 10. Please do a better job than I did. Mine's a little sloppy. But we get the general idea, right? So now instead of making bars, we're plotting these as points. So at 102, I've got a frequency of 2. 107, I have a frequency of 8. At 112 is 18, 13, 7, and 2. So you're going to connect all these points, just like we typically would for a line graph. But then you're going to, remember, it's a polygon. So it's a closed figure. Travel back in time to geometry. So you want to close this with your x-axis. I kind of figure my next bar would be right about here, so I just connect it to where that next hash mark would be and connect to your origin. It's kind of a messy connection, but there we go. All right, so there is a frequency polygon. How is a frequency polygon different from a histogram? Same data, same shape. However, it's dots and lines as opposed to bars. So they really are using all the same data, and they do show us the same shape. If you look back at this, just picture what that shape looks like. Look at this. Look at what that shape looks like. Don't make it a curve when you connect them. It's line segments for that polygon. Ogive. An ogive is a cumulative frequency. Now in 2.1b, I'm not sure if we remember to talk about a cumulative frequency table, but we will talk about it right now. So it's still going to be similar. It's going to use the same data, but it's just a different shape. And this one won't be the data we are going to use cumulatively. So remember, cumulative means add. So to construct, find your cumulative frequency for each class. Cumulative, again, always means add as you go. It's kind of like that bowling score thing. That's supposed to be a D. There you go. Then, can't remember, there it is. Label your axes. The X, this one's kind of a weird one, is the open-ended upper boundaries. The Y is your cumulative frequency. Frequency always goes on the Y-axis, always. And you're going to plot your points because you've got everything ready. And then you are going to connect the dots. This one we leave open-ended. You don't have to connect it back to your origin, and your last point will just sit up there in the air. So it's not a polygon. It's an ogive. All right, or a cumulative frequency graph if you prefer. So notice this one is an interesting one because we've got an upper bound. This is all the same data as everything that we've done all along. However, we do it a little bit differently because we've got ourselves a top limit. So this class goes up to 104, right? So if we're accumulating things, if we're adding, this is everything that is less than 104. However, we have to use this guy right here. That's why I left that extra line in our table. So we're going to say this is everything, all the data points that are less than 100. You're always going to start with that lowest class limit. And then we keep going with this. So right here, if we're accumulating, we're going to say, I want to know how many data points are less than 109. And then I'm going to say how many data points are less than 114. You're getting the hang of this, less than 119. I'm not making these numbers up. I don't need the class boundaries for this. This will be less than 124. And let's do our final one. How many data points should be less than 129? Should be all of them, right? We didn't have anything higher than 29. That's our highest class limit. So how many ever we have in our sample, that's what we should have for our cumulative frequency. Remember, cumulative adds as we go. So how many data points do we have less than 100? There's nothing, right? Because our lowest class limit. So this guy will always be a 0. Now, if I'm saying how many data points do I have less than 104, that means from here and up. Well, that's just 2. My next upper bound, whoops, is how many data points do I have less than 109? Well, that's everything from here up. So it's 2 plus the 8 that we just got, 10. This upper bound is saying how many data points do we have less than 114? Well, that's going to be the 18 plus the 8 plus the 2. Remember, it's like that bowling score. We keep adding the previous or the next number on. So that's going to be probably something like, what, 28? How many data points do we have less than 119? Well, we just put 13 more in there. So that's going to be, what, 51, 38, 41? Let's go with 41. And then how many data points do I have less than 124? Well, 7 more makes it 48. And how many data points do I have less than 129? Well, that would be all of them, or the 2 more that I just added on, so 50 data points. If I had checked those other ones, I would be willing to bet that my sample size or my n was equal to 50. So now I'm going to do this just like we did before. So the first thing I'm going to do is I'm going to make myself an xy axis. The x then is the cumulative, or sorry, the x is the upper bounds of the record high temps. I'm just going to use those upper bounds. So less than 100, less than 104. I don't put the less thans on that x-axis. I just include my upper bound. And then frequency happens to be cumulative frequency. Now notice on this one I'm using this last column over here. So it does have to go up to 50. So be careful. So I'll count by tens probably. 40, 30, 20, 10. Not the greatest, but all right. So less than 100, I have 0 pieces of data. That's always going to start at 0 again because we always use our lowest bound. Less than 104, I've got 2 pieces of data. Then 10, then 28, then 41, little jump up there, 48, and 50. Connect these guys together. Notice how it's always an increasing slope, or it could stay the same. Could your slope ever go back down? Hopefully you know that's a no, because we don't subtract, we keep adding on our next value. In this case, the graph can never go higher than 50, right? Because that's our sample size, so we can't get any larger than that. And ogives are a lot different from frequency polygons. They're different because they use a cumulative frequency rather than the frequency itself. So our shape is different. but of course they still use dots and line segments. So all that stays the same. All right. So what I would like to do is have you construct a histogram, a frequency polygon, and an ogive. I give you all the information, the class limits and the frequencies. You've got to find the boundaries, the midpoints, cumulative frequency, relative frequency, all those kinds of things. Notice that there are 30 pieces of data, so that should give you a little clue. And then I give on each part a little little questions to ask. So construct a histogram here and make sure that you're looking at those things. So double check. Do you even need relative frequency for a histogram or cumulative relative? So some of these things are on there. You won't need to use them. Pretty sure you won't need the midpoint for that histogram. You won't need midpoint until you get to your frequency polygon. So here's your frequency polygon. Here's your questions for an ogive. I put those extra little things in there if you need to see them. Remember class limits. This is always going to be how many pieces of data are less than something. So I put that in there so that you had those things. And a relative frequency graph. So this uses your relative frequencies or your proportions instead of raw data. Some people think of them as percentages. I'm going to ask you to leave them as decimals, usually to 3 places. So the graphs look the same. The only difference between a histogram and a relative frequency graph is that your scale on your y-axis is different. So compare to, I'll do this first. Your relative frequency, everybody knows, is your frequency over n, which is your sample size. And this looks the same as a histogram. The shape will be the same. So it's a bar. Relative frequency graph is bars. Your y-axis will be decimals. You'll go up to, you'll be 1 at the highest. So last but not least, shapes. So distributions are not often perfectly shaped, but look for an overall pattern. The one that we love the most in stats is a bell-shaped graph. Take a second to go back and look at that very first histogram we made. I would say, again, they're not perfect, but I would say that that first histogram we made is a bell shape. It goes up. A perfect bell shape looks kind of like this, but it's got the potential to be there. So uniform is flat or relatively flat. J-shaped, I don't use J-shape and reverse J-shape, so obviously this would be my J. This would be a backwards or a reverse J. I like the right and left skewed. We're going to use these ones a lot. So take a look at right and left skewed. People always mess up which way it is. This one would be also called a positively skewed graph, because most of our data is down here on the lower side, but these pieces are getting pulled in the positive direction. A left skewed is called a negatively skewed graph. I switch back and forth between them, so I want to say this now. Because most of our data is here on the positive side, but these pieces of data are pulling it to the left or to the negative direction. Bimodal means we have 2 modes, so I have 2 high points. It's kind of like, well, it's not bell, it's not skewed, it kind of just has 2 high points. And U-shape, I typically go with U-shape more frequently than J. It looks like a U. Again, not perfect. We're looking for trends in data. We like them when they're right or left skewed and bell-shaped or uniform. Those are really the 4 biggies. I'm going to ask you about the shapes of graphs. I believe that is it. So that would be section 2.2. Thanks so much for hanging in. I know it was a little bit of a long one, but we're going to do a lot of practicing. Don't forget to go back and do those ones. We'll talk about the ones in the middle of the notes. Have a good one.